All right. We're going to look at what we started earlier, Surds. And this is volume 5 of Surds. Tonight, we are going to continue with where we ended yesterday. Tonight, what we are going to do is continuation of rationalization. So, continuation of rush. Okay, so rationalize, okay, zation. All right, continuation of rationalization. Okay, so without wasting time, let's set the ball rolling. Now, rationalization, okay, of the denominator. Okay, so we say rationalization. Rationalization okay, so we are going to look at rationalize the denominator of a set. So rationalize okay, rationalize the denominator of surd. Right. So when we talk about rationalization, or as we're talking about rationalize that denominator of a surd, what does it come into mind? Well, as we saw earlier, if I have this expression, if I have 8 over 2 plus surd of 3, okay, and if I have 9, you see, if I look at both of them, you see here 3 and a surd of 9 are irrational. Okay, so we can say that surd of 3 is irrational. In the same way, surd of 9 is also irrational. Okay, irrational. So, to be able to make it irrational, I have to make something to do with the denominator. Okay, so in effect, what we are trying to do is to make the denominator rational. Okay, so to make, yeah, so when we say rationalization, to rationalize is to make the denominator, okay, to make the denominator a rational number. Okay, So we are going to see how we'll go about it. Okay, so let's call our first expression we have here to be A and the second one to be B. So we are going to see how to make these two expressions rational. So we will start by tackling this ideology. Okay, now let's look at it. Yesterday we started it sparingly, but I realized that people were tired, so that is why we stopped. Okay, but now we are fresh, we are back. So we are going to take it step by step and work it out. So now we have 8 over 2 plus set of 3 and 11 set by 11 by a set of 9. Now let's see. Let's tackle the first one, which is the B part. The B part. Okay, so the B part, let's see. It's 11 over set 9. Okay, to rationalize this, I have to multiply the whole expression by the denominator. Yeah, this denominator is what I'm going to use. So at the moment, my denominator is 9, which is a set of 9. So I'm going to multiply the top by a set of 9 and down by a set of 9. You see, if I do that, you see, remember yesterday we said something. If I have set A multiplying set A, the answer is set A. Remember, and if I have set B multiplying set B, I'm going to get B, sorry, it's A. If I have set of 50 multiplying set of 50, I'm going to get 50. Yeah? So, with that knowledge, even if I have, with this knowledge in mind, let's look at it again. You will see that set this one means set 9 over set 9 is nothing but what? 1. When you divide set 9 by set 9, it's 1. So if you look at it, it seems like I have 11 set of 9 multiplying by 1, which means I haven't changed anything. Okay, so that is what we are bold enough to say that if we have set 11 divided by set 9, since I want to rationalize the denominator, okay, I'll multiply here by set 9 and here by set 9. And I know the numerator, which is the bottom one, this, will give me answer of 9. Okay, so that I would say that the set is now given as what? 11 set 9 over 9. You see? So now you see that a 9 is now a rational number. You see, now 9 is a what? A rational number. Rational. So that's the reason why we do rationalization. Well, let's look at the first part of the question. We have 8 over 2 plus root 3. 8. Okay, 8 over 2 plus root 3. That's the A part. Okay. So that, let's go back here, 8 over 2 plus root 3. And we're supposed to rationalize this. Okay, we're supposed to rationalize this. We're supposed to rationalize it. So, yesterday I was trying to explain something we call an equation we call the method of two squares. So if I have a squared minus b squared, it's always given as a plus b into bracket a minus b. You see? So a plus b and a minus b. This equation, as we can see, okay, is called method. Okay, method of two squares. Okay, it's called method of two squares. Okay, some people prefer calling it method. Some people prefer calling it another name. Some people say difference. Difference. Let me clean this. Okay, some people call it difference of two squares. Difference of two squares. Okay, so some people call it difference of two squares. Yeah. So this very equation is going to help us a lot when we are doing our calculation in set. Because if, for instance, if the A is equals to certain set and a B is equal to certain set. So let's give ourselves something simple to do. If we have A to be set 3 and B to be set 2, okay, and we will come across this, okay, like we have set 3 squared minus set 2 squared. You see, when we see something like this, well, what it comes into our mind is to implement our equation, which is difference of two squares or method of two squares. Okay, now let's look at it. With our equation, since we know that the equation is given as this, okay, as this, if we are going to apply it to solve this one, if we, from observation, when we squared set of 3, we know that it's to be set of 3 times set of 3. And that will give us 3. When we squared set of 2, to be set of 2 times set of 2, and that will give us 2. After that, when we subtract, we are going to get 1. 3 minus 1. 3 minus 2 is 1. Okay, so if we apply this rule or this equation, okay, then our answer is going to be set of A is root 3 okay, let me come here. All right. All right. So set of A, okay. So set of A is root 3 into bracket plus set of B, which is root 2 into bracket, and the same thing, set of 3, which is minus set of 2. You see, so all what we've done is we have implemented the formula by substituting the respective values into the formula. So, when we look at this, okay, if you want to work it out, as I said, let's call this one the left-hand side. Okay, the left-hand side, and this the right-hand side. Okay, and let's evaluate it and see what that this formula holds. And this formula we are going to use it throughout. Please have a clear look at this formula so that when we are ready to use it over and over and over throughout, working with surds as far as rationalization is concerned, the method of two squares or difference of the two squares formula, we're going to use it throughout. Now, let's see. Let's tackle the first one. We are going to prove that the left-hand side is equal to the right-hand side. So what do? We tackle the left-hand side first. So our left-hand side, okay, so implication of the left-hand side. Yeah. Okay, now let's see. Without question, okay, we know we have root 3, set of root 3 squared, okay, minus set of root 2 squared. That's the left-hand side. So how do we simplify this? We know when we simplify this, okay, look at it, this and that, okay. If we look at it, this will be set of 3 times set of 3, okay, and this will be set of 2 times set of 2. What do we know? Once again, we know that one set one as identical set of the same value are multiplying to it itself. It's the set itself. So this, you see, this we say all subtraction minus. So we put a bracket sign around it so that it will be easy for us. Now we know that when we multiply set 3 by set 3, our answer will be 3. And set 2 times set 2, our answer will be 2. Bear in mind, we have minus here. So this means our answer, as we calculated from the left-hand side, is 1. Okay, so that is our first evidence. Okay, first evidence. Now let's look at the other one, which says that that's the right-hand side. Okay, so let's look at our right-hand side. Our right-hand side, okay, that says the set of 3 plus set of 2 minus set of 3 set of 2. So this is what we had. Okay, so how do we expand this? We have to expand this to verify that the left-hand side is correct to the right-hand side. So since this one is 2, let's write it well, 2. All what we have to do is to take the first one. You see the first number, multiply by this, by 3. Okay, and the same number goes to multiply 2. And we write the answer. Okay, so the first one, root 3, is going to be root 3 times root 3. So this root 3 multiply this, and this minus root 2 times root 3. Okay, now this is our first expression. Okay, now the second one, we are going to use this number, okay, the 2, to multiply this one, and after that it multiplies this one. You see? So now let's see. With that, we are going to get root 2 times root 3 minus root 2 times root 2. Okay, now this expression, as it is, they are together. So we are going to write it in total. So this, the first one, as we know, is root 3. So root 3 times root 3 minus root 2 times root 3 is 1. Okay, plus root 2 times root 3 minus root 2 times root 2 to bracket. Okay, now when we simplify this, we know that when we multiply this and that, and this and that, and this and that, and this and that. Okay, now what do we see? We know that when we multiply root 3 by root 3, we have 3. Bear in mind we have a minus here, and root 2 times root 3, we apply the principle we know. That's a 2 times 3, okay? Then plus this the same way, 2 times 3 minus, and this is root 2 times root 2, that will be 2. Okay, now this, we can further say 3 minus 2 times 3, that will be 6. So that's minus root 6 plus root 6 minus 2. Okay, now let's look at it. This minuses pluses is 0. So we're going to have 0 minus this minus. Okay, yeah, this minus, so this is plus. So we have this to minus that, so minus 6 plus it, that will be 0. So plus minus 2. So finally our answer is going to be 3 minus 2, which our answer once again is 1. You see? So you see that we have been able to prove or explain that the answer we get for the left hand side is equals to the answer we get for the right hand side. So this meaning, this equation, as we made mention of earlier, called method of two squares, or method or difference of two squares, is going to help us a lot when it comes to our rationalization. So now, with this knowledge of this method of two square, we realize that instead of going all all the way long, okay, instead of going all the way long to the way we saw this equation, if perhaps we did our calculation and we saw that we have 2 squared minus root 3 squared, okay, or what we do is this 2 squared minus that. To implement this, we know that it's going to be root 2 minus root 3 into bracket 2 plus root 3. You see, this left-hand side will straightforward help us to calculate our answer, to know that when we square 2 is 4, and when we square root 3 it will be 3. So this will help us to get the answer. So this left-hand side, we are going to use it constantly, because this is what we are going to use to evaluate this to get our answer. So immediately we see the right-hand side, okay, then we compute it with the left. So when we see the right-hand side, okay, so when we see an expression like the right-hand side, RHS, then we will shortly use the left-hand side to evaluate. Okay, so that's what we do. So most often than not, you will see that even though we will have this expression like this all the way, but this is what will help us to compute it easily. Okay, so now let's see what I'm talking about. Right from the onset, there was a question we came across that says 8 over 2 plus root of set 5. So let's look at it. That example, we had 8 over 2 plus set of 5, and we're supposed to rationalize this. So how do we do it? So first of all, we take our denominator. So this is our denominator. Okay. Denominator. Okay. So now step 1. Step 1. Select the denominator. Okay, and step 2. Step 2, change the sign. Change the sign. Okay, so how are we going to change the sign? For instance, over here, as we implement step 1, that's we should pick out denominator. So our denominator, in this case, is 2 plus set of 5. And the step 2, this is a step 1. Step 2 says change the sign. So our sign is going to be 2 minus set of 5. Because see, we have, over here we had plus. So we will change it, become 2 minus 5. Okay, then third, step 3. Yeah, step 3. Multiply Okay, so step 3, multiply both the numerator okay, so step 3 is to multiply both the numerator and the denominator by the result of step 2. Okay, result of step 2. Okay, so we are going to multiply the numerator and the denominator by the result of the step 2. The step 2 says we should change the sign. So the one that we've changed the sign is what we're going to use. So our question, as we saw earlier, was 8 root 8 plus 2 root 5 or root 3. Okay, root 5. That's why it is. Okay. Okay, so 8 that. So now if we take this question, okay, our denominator, now we know the denominator. So we are going to multiply the denominator by the step 2 1, which is 2 minus set of 5 divided by 2 minus set of 5. Okay, so when we get something like that, it means this one, if I put bracket around it, it's multiplying this. Okay, so when we see that we can simplify the expression, okay, let's simplify the expression. Okay, you see, the expression now will be equals to this 8 into bracket 2 minus set of 5 all over. Don't forget our rule. You see, all over 2 squared minus set 5 squared. Why am I saying that? You see, I've put the expression this way because of what we learned earlier. Okay, we learned that this method of 2 squares will always help us when we're doing our rationalization. So you see, this is 2 plus set of 5 into bracket 2 minus set of 5. Okay, and when we see that, this, okay, it means what? 2 squared. You see, 2 squared minus set of 5 squared will give us this. So that is the reason why I have written it this way. So now all what we have to do is to do a simplification. Okay, simplify it to rationalize it. So when we simplify, we know the top one, 8 multiplied 2 minus set of 5, and this we have 2 squared minus set of 5 squared. Okay, on the top one we are going to get 8 multiplying 2, okay, 2 minus 8 multiply set of 5. Okay, And the bottom one, we know this square root of 2 will be 4. And we know when we squared set of 5, meaning set 5 times 5 will be what? 5. So our further simplification will be 8 times 2 is 16. Okay, so see, 8 will tackle this, and it will give us 16. This will tackle this, and this will give us minus 8 set 5. All over 4 minus 5. So which eventually, our answer will be 16 minus 8 set 5 all over negative 1. And finally, negative 1 dividing through will give us our answer to be negative 16 plus 8 set 5. So this, you see, the denominator has become rational. So that's how we rationalize it. Okay, so that is the process. Please take your time and look at it from this point. Our question was 8 set of 8 over 2 plus set of 5. Okay, we're supposed to rationalize. Then I've given you steps. The step 1 is all what we have to do is to select the denominator, which you know the denominator is your 2 plus 5, as you can see over here. Yeah? Then after that, you make the denominator, you subtract, you change the sign. So this one becomes 2 minus 5. Then step 3 is multiply both the numerator and the denominator by the result of step 5. So over here, you see 8 over 2 plus step 5 multiplying by the denominator and the numerator. And when we did that, we expanded it. Okay, so we had this. Now at the bottom here, we applied a method of 2 squares. Okay, and as I said, anytime we see this, we know it's the same as this one. So instead of writing, see, this one is the one beneath. So meaning, instead of writing all this beneath, we write the left-hand side. So we'll replace it here. Then after that, we did expansion. We simplified it. Okay, 8 multiplied by 2 is 16. 8 multiplied by set of 5 is minus 8 set 5. Okay, and when we squared 2, we get 4. When we squared set of 5, we get 5. We subtracted, we had minus 1, and we multiplied 2 by minus 1, and this is where we are. So that's how we do said. Okay, now, let's tackle one more question. Okay, let's tackle one more question, and we'll see the best way to move forward with this. Okay, our next example. Okay, it says rationalize. It says rationalize the denominator. Okay, now when you look at it, okay, our question that we have been given is 8 plus set of 10 divided by set of 10 minus 1. You see? Fantastic. So first and foremost, what do? We select our denominator. Our denominator is 10 set of 10 minus 1. Okay, the next step we have to change the sign. Okay, once we change the sign, this one will become set of 10 plus 1. So this is what we are going to use. Okay, so we know the question given is 8 plus set of 10 all over set of 10 minus 1. So we are going to multiply this result to both sides. So this one will be set of 10 plus 1 all over set of 10 plus 1. Okay, so we haven't changed anything because set of 10 plus 1 divided by set of 10 plus 1 is 1. So we haven't done anything. So what do we do? Now we are going to apply. We are going to apply our properties of set. Okay, now we know these two are multiplying. So then we can say this is equals to 8 plus set of 10 into bracket set of 10 plus 1 into bracket. Okay, all over our equation set of 10 minus 1 and set of 10 plus 1. Please, when it is straightforward, you see that the bottom one, this one, you have to apply your rule, and that will make life easier. What do we do? Our rule that we know, that's method of 2 squares. Okay, you know when we have a squared minus b squared, it's always given as what? A plus b and a minus b. That's what we are going to apply to evaluate that denominator. So we see that over here, this our a is what? Set of 10, and our b is 1. So when we put this one in the equation, we are going to get set of 10 squared minus set of 1 squared. And that will give us set of 10 plus 1, then set of 10 minus 1, which is the same as what we have here. Okay, so, and we know here, one set of 10 square will give us 10 minus this, and the set of 1 squared is 1. So our denominator is now 9. So we are sorted. Now we'll go back to concentrate on the top. So then we have 8 plus set of 10 into bracket set of 10. This 8, this set of 10. Then this one plus what? All over 9. Okay, so our headache right now is to solve the numerator, and that is easy as well. The numerator is easy. How do we do that? We've done that already. So we will multiply. Let's take our green to make this an illustration. We use the 8 to multiply this. Okay, and after that we use the same 8 to multiply this as well. Okay, then we will use the 10. Okay, we use the 10 to multiply the 10 here, and the same 10 will multiply 1. Then we write the answers in addition. Okay, so when we do that, the green. So this, the top one, okay, this, the first one is 8 multiplying set of 10. Okay, plus the same 8 multiplying 1. So we finish. We can put bracket around it. Okay, we say plus. Now the next one is set of 10 multiplying set of 10. Plus, this is set of 10 multiplying what? So set of 10 multiplying 1. Then we are done. All divided by our 9. Okay, so we do further simplification. We know that when we multiply set of 8 times that will give us set 8 set 10 plus 8 times 1 is 8. Okay, then this one, set of 10 multiplied by set of 10, here we get 10 as well. And set of 10 times 1 is set of 10. Okay, so all over 9. Okay, you see, I've broken it step by step so that we don't get confused at all. Because it's very important to break it down step by step so that you'll be able to understand it. Now, I'm going to group the like terms. So I know this 8 plus 10 will give me 18. Then I'll be left with 8 set 10 plus set 10 all over 9. Okay, which we can go further to add. You know, when we add 8 set 10 plus set 10, you see, since we have set 10 as a common value, like this, you see, set of 10 and a set of 10. Okay, it means when we add them together, it's going, this 18 is here already. This will be 9 set 10. So plus, there's a 9 set 10 all over 9. Okay, all over 9. What do you see? We can still further divide. Yeah, we can still further divide because 9, look at it, 9, we cancel itself 1, and it goes, we cancel here, and it goes here 2, and we cancel this 1. So our answer will be, now it goes to 18, 2. So this is 2, and now we cancel this, plus root 10 becomes the final answer. So you see that we have rationalized it. Well, let's recap, okay, and bring it to final fusion. See whether we've done something good today. So now let's look at this example. Now, first and foremost, this was what we were given. Okay, our question was this. Okay, this. So, as we learn, when we are doing rationalization, we always pick the denominator. And the denominator we pick was set 10 minus 1. The second step says that after you have picked your denominator, you have to change the sign. And our sign here was minus 1. So we change this sign to be set of 10 plus 1. You see? And our third step is we have to multiply the set question by the selection 2. So you see that set of 10 plus 1, we multiply the numerator by set of 10 plus 1 and denominator by set of 10 plus 1. Because this 2, if you combine them, it's just 1. After that, we wrote it like this expression, putting a bracket around it. Okay, now the denominators, as you can see, here is minus and here is plus. And we have root 10 is the same as root 10, and 1 over here is the same as 1. So we remembered our equation we learned that is called method of 2 squares. Okay, then we said A is instead of root 10 and B instead of 1. Then we'll put these respective values back into the equation. Okay, then we're able to deduce straightforward that the square of A be set of 10 squared minus set of 1 squared. When we simplify, when we squared 1, we had 1. When we take set of 10 multiplying set of 10, we had 10. So 10 minus 1 is 9. So that helped us to deal with the numerator, the denominator. So our denominator became 9 over here. Okay, now numerator is what we have to compute. And as I've illustrated, you see, you pick the 8 and multiply the 8 by 10. Okay? After that, the same 8 will go and multiply the 1. So the 8, you see, multiply 10, 8 multiply 1. So 8 multiply 10, that's I wrote it here. And 8 multiplied 1, I wrote it here. When I was done with it, I picked the next value, which is 10. And the 10 multiplied by 10. You see, there was a set of 10 multiplied by a set of 10. That's what we had over here. Okay? This is this. Okay? Now, the next one we did was set of 10 also multiplying 1. That's what we are. Then we'll put them together. We know 8 times set of 10 is 8 root 10. And 8 times 1 is 8. Plus set 10 times set 10 is 10. Okay? So plus 10. So you see, we can't add this. We have to add the like terms. So the like terms, we have 8, okay? Our 8 here, we added it to a 10 over here. Then we have 18 here. Right? Then after that, we brought 8 set 10 here and plus set 10, all divided by 9. And we know that these two are adding together. We all knew that sets cannot add together, but unless there's an identical values, you can compute. So this 8 set 10 plus set 10. We know in front of set 10 is 1, but we normally don't write the 1. So we said it's set 10. So 8 plus that 1 gives us 9, and set 10 comes together. So this becomes 9 set 10. Well, let me explain it further for you to understand what I mean by that. Okay, you see here, we did something before. Let me bring it this way so that we can use it to do our explanation. So if I have 8 set 10 plus set 10, all what it means is when I factorize set 10 out, okay, I'm going to get 8 plus 1 into bracket set 10. You remember we did it yesterday. So the 8 plus 1 will be 9. Multiplying set 10. So it gives us 9 set 10. So that's the reason why we have 9 set 10 over here when we computed this 2. Okay, so after that, we have 18 plus 9 set 10 divided by 9. And when we did a division, 9 goes into 18 twice. And now we'll cancel 9 over here. And we had 1 set 10. So that is the final answer. Well, thank you very much for today. We will continue. But before we finish, I think I will leave this question here. So the next time we'll meet again, that will be our continuation. All right. So the question here says, you can try your hand. You can try your hand on this question, okay? You can try and work it out. This is set of 250 minus 2 set 90 plus into bracket set of 5 plus 3 squared. Yes, please, this is the question. So try your hand on it, okay, and we will discuss it. Try it. I know you can do it. Well, you can email me your answer, okay, so that we all, have a look at it before we come here. Well, thank you very much once again. And I'll be pleased if you can go in there and subscribe and also like the videos. And you can also click the bell so that you will keep receiving the discussion we've been doing. Thank you very much. Bye.